Hello everyone, welcome to my channel oneconceptelectrical. This is one of the DC machine question on compensated winding. Here they are asking to find total number of conductors of compensated winding placed in each pole. Total number of conductors of compensated placed in each pole. Let's go for a basic data. Here they given the terminal voltage of 400 volts and 14 poles, and given total number of armature conductors is 1100, and they given pole arc by pole pitch of 0.7, given zero point 0.7. Here by this data I am calculating IA. Here they given output power SP equal to 2000 kilowatt. Then I am found armature current of 5000 amps. We know that suppose this is a north pole, this is a south pole. We already know the armature MMF will peak along interpolar axis. This is interpolar axis. The main use of compensated winding is to reduce armature reaction across pole shoes. Means this is pole shoe or pole arc. This is pole pitch, like from this end to this end is pole pitch. In order to find compensated winding across the pole face conductors, we need to use the ratio of pole arc by pole pitch. By multiplying pole arc by pole pitch into armature MMF, we'll come to know how much MMF is required to reduce armature reaction across the pole shoe region. That's why this formula is nothing but an pole arc by pole pitch into MMF of armature per pole. By substituting the data in this particular formula, pole arc by pole pitch is in 0.7, pole arc by pole pitch is in 0.7, and Z is in 1100, 2 PIA by A. Then I found the compensating winding MMF is 98 to 1.4 ampere turn per pole. They're asking for total number of pole face conductors. Means per pole how many compensating winding conductors are there. We already know MMF is a formula of N into I. N is total number of turns of compensated winding in each pole and current. We already know compensated winding in armature is connected in series. Then I is equal to IA. Then I found total number turns per pole is 1.964. We already know one turn is equal to two conductors. Then multiplying with the factor of 2, then 1.964 into 2 become 3.92. By rounding off, it became 4 conductors per pole. Means per each pole, there should be at least 4 conductors of compensated winding should be placed. Means this 1, 2, 3, 4. If you place the 4 compensated winding conductors, it will produce an MMF like this. Produce an MMF like this. This MMF will try to compensate armature MMF, means it will compensate this one and this one. This will both cancel each other. This will cause reduction in armature reaction. It will lead to reduction in armature reaction. Reduction in armature reaction. If the armature reaction is reduced, then the armature flux impact on main field flux will also reduce. It will help the DC machine.